Hey everyone, welcome to Exercise Check. In this video, we're going to be going over the exercise for inheritance that can be found in 7.8. Let's get started. As always, it wants us to start out by opening that Java Web Dev Exercises project in IntelliJ, and then creating a new package called Technology in our Exercises directory. Let's go ahead and do that. So we're back into IntelliJ. Inside of that project, we go into our Exercises folder, and it said we need to create a new package called Technology. So I click Package, and then I say Technology. Press Enter, and our new package has been created. Great, let's move on. In this one, it says we need to create a new class called Computer. Before we add any more code, we need to note that we're going to be adding additional classes called Laptop and Smartphone. So before we do anything, it says we need to diagram these three classes, how they're going to be related to each other, and then add properties and methods to your diagram. All right, so I'm going to get out a pen and paper and go over just a quick diagram of how I would do this. For this part of the exercise, they want us to make a diagram of how we're going to implement these classes. Those classes, again, being computer, laptop, and smartphone. So first things first, we need to figure out how they're going to relate to each other. Well, I say computer. Computer is a pretty general word. Anything that crunches numbers is technically a computer. Laptops are a little bit more specific. As we know, there's something that go on our lap and we can actually program or we can watch movies from. Smartphones differ from laptops. They allow us to make phone calls, FaceTime with friends, etc. But laptop and smartphone are still something that can crunch numbers. They're still computers. So therefore, I feel that laptop and smartphone are direct descendants of computer or children of computer. All right, now that we have that simple diagram written out, let's go ahead and create the classes to begin. I'm going to first create the computer class. Perfect, created that. Now I'm going to go ahead and create the smartphone class. Finally, I'm going to create the laptop class. From our discussion in that diagram, we know that laptop and smartphone are both related to computer. So how I do that and show inheritance, I go to the laptop class that's related to computer, and I said it extends computer. This means that anything I program into computer will be passed down to my child, laptop. We're going to do this with smartphone as well. Great. We have these classes created, and now they're related to each other. So let's see what else the instructions want. For the parent class, we need to add 3 properties, 2 methods, and a constructor. That keyword being parent class. As we said in our discussion, our parent class is the computer class. So I'm going to copy what it wants here and bring it over to the computer class. All right, let's start doing this. At the top, we always know we have to put our class variables. It says we need 3 properties. Now for these properties, they didn't give us too much context of what they were looking for. So I just came up with 3 properties that I feel that a computer has that also a laptop and a smartphone would have. The first one is a screen width, which is going to be an integer. With width, there's usually a height. So I'm going to create a screen height. Then finally, I want to know how old my computer or my technology is. So I'm going to have a manufacture year, which I'm going to set to a string, not a date, because I just want to store that year. If you're asking yourself, why did I not store this year as an integer? It's just a personal preference. I just want to store it as a string. So next, after our class variables, we always have our constructor. It says we need to add 1 constructor. So that's what I'm going to do here. So there we go, we've created our constructor. Of course, after that, my methods. I'm going to just come up with 2 methods that I feel like a computer would have. The first one is a very simple one, which is processing 2 plus 2. In this one, it's going to add 2 plus 2 and then return the int, which I hope will always be 4. So to do that, I'm going to return 2 plus 2. The next one is going to be just another method that I came up with, which is going to be the tell me a joke method, which won't return anything, because instead of returning anything, we're just going to print a joke out to the screen. There we go. We've created 2 methods, we created 1 constructor, and we've created 3 properties. Exactly what our task asks us. Now let's take a quick look at an issue that we're having. It says 2 related problems up here, so what's going on? looks like we go over to the laptop class, it's not happy with something. It says there is no default constructor available in exercises.technology.computer. Well, what this is saying is that we created a constructor in computer, and because laptop extends from computer or inherits everything from computer, laptop is expecting us to call to that constructor inside of its parent. So what does that mean exactly? The parent is basically demanding the child to do whatever it does. It's like a very authoritative parent. And in Java, if it ever deviates from what the parent wants, well, then we get yelled at. So what this is saying is that in here, we need to create a constructor that makes our computer parent happy. So let's do that real quick for laptop to fix this. Laptop extends from computer, so I know it needs to take in a screen width and height, as well as a manufacturer year. To call to the parent's constructor, we use a new keyword that we haven't really used yet, which is super. And then we plug in here what the parent wants us to send back to them. Remember, they're demanding us act just how they did. So we have to pass in our super, that screen width, screen height, and manufacturer year. And now this problem has been solved. Now it's happy. However, we see that smartphone now is complaining as well. Well, that's because it has the same problem that laptop did. So I'm going to copy laptop's code, bring it over to smartphone, and switch out laptop for smartphone. And now everybody's happy. It's a happy family once again. Perfect. Let's go back to our instructions and see what else we need to do. For a child class, add at least one additional property and one additional method. Well, that sounds easy enough. Remember, child class is our keyword here. Child is whatever extends the parent. In this case, it's laptop and smartphone. So let's go ahead and go into the laptop class and add a property that it wants. Properties or class variables always go at the top. In a laptop, I know that one thing that sets it apart from the smartphone is that we can have IntelliJ on a laptop. It actually took me some thinking here to figure out what we could have different from a smartphone and laptop. They're getting very, very similar. So in this one, I'm going to say, is IntelliJ opened? And it's going to be a Boolean. Then we have our constructor down here already. So I want to set is IntelliJ opened here to, let's just say, false automatically. Because when our laptop boots up, maybe IntelliJ doesn't open immediately. So I'll say is IntelliJ open equals to false. And then I put this in the front. Do note that I put this setting of this property below the super. This is standard. You should always place your super at the very top of the constructor. If I don't, bad things happen. Perfect. But what if I wanted to pass in IntelliJ is open into the constructor? Then I overload the constructor. So I pass in the Boolean here, is IntelliJ opened, and I place that down here. Remember, we also pass in that super no matter what constructor we're in, and super is always at the top of our constructor. Perfect, we finished creating this constructor, now we're on to methods. And this one, again, I really had to think hard about what we could do in the laptop that we can't do in the smartphone, and I'm going to stick with the IntelliJ example. So I'm going to call this method openIntelliJ, which isn't going to return anything. And all it's going to do is set is IntelliJ open to true. And I'm going to print out to the screen that IntelliJ is now open. Perfect, we have these methods. Let's go over to smartphone and do the exact same thing. As always, we need to create one of our properties. In this one, I'm going to also have a Boolean. And I'm just going to say is connected to 5G, which since 5G is a brand new thing coming out right now. In this constructor, I'm just going to pass it in here automatically. Just like that. I'm not going to overload this constructor just because I don't want to. Now I make that method. This one, I'm going to say make a phone call. And I'm going to pass in the person I want to make a phone call to. And let's say pass in the number that I want to make a phone call to. Remember, phone numbers have dashes and parentheses typically in it, so it's not technically a number, it's actually a string. So I'm going to print out to the screen that I'm calling this number. There we go. We created our method. We enhanced our constructor, and we created that single property. Let's go back to our instructions and make sure that's all at once. Looking good. Now we have to go on to the second step, class implementation. Implement a design and test it in program.java.class. All right, let's do that first. It says we need to do something, program.java.class. Well, I don't have that yet, so I'm going to create that class, program. And what I want us to do in here is to test our implementation. To test our implementation, we need to run our Java project. In order to run our Java project, we need to have a starting point. So we create a main in this program. This is a typical standard of a Java application. We want to have our starting point in a class all by itself. This is because now we know exactly where that starting point is, and we can do all of our tests and coding inside of this program that works with our other classes we just built. Computer, smartphone, laptop. So in that case, I'm going to do that right now. I'm going to create a smartphone. In here, of course, I have to pass in that screen width, height, manufacturer year, and is connected to 5G. So I'm going to say 500. I'm going to go with, those are millimeters or something. I'm just doing a test here. Manufacturer year, let's say 2021. And it's true because it's 2021 and we're connected to 5G. All right. So the smartphone method that I created was called make phone call. So I'm going to say 314-555-0123. Let's go ahead and run this and test it out. Perfect. Calling that number. That's exactly what we did. We printed it out to the screen. Well, let's try one more thing. Let's call to our parents' methods. Remember, smartphone extends computer. Therefore, it brings in all of computer's methods inside of it. So my smartphone dot process 2 plus 2. Remember, process 2 plus 2 returns 4 inside of the computer class. So I'm going to create a variable to catch whatever comes back from that method, and then I'm going to print it out to the screen. And I'm going to comment out what was printing out to the screen last time and run it. The result is 4. Awesome. We are calling to our computer's methods here. This is how we can utilize inheritance to call to our parents' methods to help us out in one of its children classes, in this case, smartphone. All right, well, so we tested out smartphone. Let's go ahead and test out laptop. We're going to make our laptop a little bit bigger. Perfect. So I'm going to call to open IntelliJ because that was one of our laptop's methods. Comment out that system.out there and run it. IntelliJ is now opened. Awesome. Now let's, from our laptop, call to that process 2 plus 2. Comment out that line up there. Int result equals, and then print this out to the screen. Run it. And our laptop result is 4. Great. Everything seems to be working here. One more thing, let's go ahead and create a computer. We'll make it the largest. Now, my computer.process2 plus 2 is able to be called. Let's put that out there and print it out. There we go. So it should hopefully print out computer result is 4. Fingers crossed. Perfect. There it is. All right. But if I tried to call to, say, open IntelliJ or make a phone call from computer, we see that it doesn't exist. These two methods do not exist on computer because the computer is the parent. But open IntelliJ and make phone call are methods inside of the child. Inheritance only goes one way. It's a big thing to note. So great. After talking about that, we are ready to move on. The next thing we need to do is add 3 JUnit tests per each class we just created. So let's go back to IntelliJ and do that. Before we do anything, we always need to make sure that we split our classes and our tests into 2 different packages so we know where each thing lies. So within this technology package, I'm actually going to create a main and a test package now. The first one will be main. Within main, I'm going to drag and drop all of these classes we just made into it. Press refactor. And now it's all within there. The next package I'm going to create is tests. Make sure you take out main, put in tests, press enter. Now 2 different packages are created. As it said, we need to create 3 JUnit tests for those 3 classes we just created. The first one I'm going to do is computer, which I'm going to call computer test. And that class has been created. As always, to start out our test, we have to do the annotation @ then test. We always start out that test with a public and then void, and then the name of the test. In this one, I'm going to test a constructor. So I'm going to call it constructor sets values test. And here, I want to make sure that when I pass something into the constructor, the properties of the computer class are set properly. To do this, I need to first create an instance of the computer class. So I say computer, my computer, and then I plug in my width and height, and then the manufacturer year. We're getting red here because we have not imported the class, so we press import class. We say we want to import our computer class from technology, and then there we go, we've created the new computer. Now I need to test if my constructors set all these properties properly. To do that, we have to get the properties from the computer. How we usually do that is through a getter. Going to computer, I see that I have no getters yet. So that's what I need to implement now. Getters always go at the top of my methods. So I'm going to create 3 getters, just the getters, for screen width, screen height, and manufacturer year. And there we go. My 3 getters have now been set. So let's go back to computer test now. I need to test 3 properties to make sure they were set properly. The first one will be the screen width. So as always, to make sure that 2 things are equal in a test, we say assert equals. The first value of this is always the expected value, which I know I hard-coded as 3000. Then it's the actual value. The actual value is what's returned from the method. In this case, I need to use the getter to see that. And now we've created our assert equals. We go over here and we see assert equals has red on it. It's because we have not imported it yet. So we use import.static org JUnit assert equals to bring that into our test. Next, we have to test out the height and also the manufacturing year. So I'm going to copy this line and paste it twice. The height was 5,000, and we say get screen height. And then we say 2021, and then we get the manufacturing year. Perfect. Let's run this. And we see our test is passing. Let's quickly create one more test to test out our process 2+2 method. I'm going to call this test 2+2 returns 4. We create that computer class, and then we're going to call to that process 2+2 and get the result. I'm going to pass result into the actual, because that was what was returned from my method, and the expect is going to be 4. I'll remove the other 2 assert equals because I pasted those from the last test, and we run this one. Perfect. Now let's run them together to make sure everything works. Awesome. One thing to point out is that I've created now 2 constructors here for my computer. If we wanted to eliminate this line of code, one thing you might have known that we could do is consolidate this using the @before tag. How we could have done that is that we could call my computer up here and then use the @before tag and then create my computer. Then we can remove these computers and say this.mycomputer. Now let's run that. And we still get passing. What we did was just consolidated that same line of code that was in both of our tests into this @before statement. Remember, before will run before any of our tests do, meaning that my computer will be constructed on this line before our tests are ran, meaning we can utilize that class variable now to run our tests. This helps just eliminate a little bit of code. All right, let's move on and create another test now for laptop. Here, I'm going to copy what I was doing in the computer class, but instead of computer, I'm going to have laptop. As always, import the class, and now we need to switch out my computer from my laptop. There we go. So now we're testing out the laptop properly. One thing to note is that we added an extra parameter here in the constructor of laptop. I'm going to add that here to just enhance our tests. That additional parameter is IntelliJ opened. So I'm going to put true. Perfect. Now we have to come back down here and again check our constructor to see if it's setting all the values. We need to see if is IntelliJ opened within our laptop class is set to true. But we don't have a getter yet in laptop for that. So let's go back and add that now in laptop. As always, getters go above all of our other methods. So we say public boolean get is IntelliJ opened. Then we return that class variable. Perfect. I'm going to copy this class name, come back over to laptop test, and then paste that in there. Now we're checking if laptop's personal property is IntelliJ opened is returning true in this test. So let's go ahead and run this. Oh, I see I'm getting back a failing test. It's because the expected was 3,000 and the actual is 5,000. But my question is for what? Well, looking up here, 3,000 was what was expected, but I was getting here the width back as 5,000. Well, that makes sense because in laptop, I actually switched accidentally the screen height and the screen width. What do I mean by that? In laptop, in its constructor, it goes screen height and then screen width. But if we go over to computer, in its constructor, it goes screen width to screen height. So I accidentally flipped this in my code. So how do we fix this? Well, here it's asking for the screen height. So 5,000 was my screen height in this example. My screen width was actually 3,000. So I just flipped these two parameters. So let's run this again now. There we go. Now everything's passing. Perfect. Just like in computer, we need to test out the laptop's own method, open IntelliJ. So I'm going to call this one open IntelliJ sets is IntelliJ opened to true. So I'm going to clear out all of this here. And now I need to prepare this test. What I'm saying is that when I run this.mylaptop.openIntelliJ, this method should set is IntelliJ opened to true. Now, a problem we're going to have with that is that, as you know, in my constructor, I already set it to be true, meaning we're going to have a hard time testing this because it's already been set to true. So what I can do here is create a setter within laptop for is IntelliJ opened to set it back to false before we test it. So I'm going to create a setter now for this. Going back to laptop test, now I'm going to set is IntelliJ opened to false before we even start running this test at all. So we set it to false. We then open IntelliJ, and now we have to check to see if an open IntelliJ is actually set to true. So I'm going to take that assert equals from my previous test and place it down here. So let's go over real quick what this test is doing in full. This is going to set is IntelliJ opened to false. This will set it to true, and this will test if it's actually true by using that getter. Let's run this. And we see now it is passing. Perfect. But what if we don't trust that this actually set it to false? Well, then we can enhance this test by one more step. What if we put this assert equals here, and instead of true, we say false? Again, this is the setter, so it should set is IntelliJ opened to false, and we're going to test that. Let's run this again. It's still passing. That means both of these asserts actually do pass. Let's move on to smartphone. As always, we're going to go over to laptop test, copy what we just did with the constructor, as well as the before tag, paste it into here, change out laptop or smartphone, import that class, and we see that our constructor is taking in that screen height, that screen width, the manufacturing year is now is connected to 5G, which is true. Down here in this test, we need to correct this a little bit more. We replace my laptop with my smartphone. We do not have this getter in smartphone because is IntelliJ open doesn't exist with smartphone. So let's hop into the smartphone class. And now we need to create a getter once more for that is connected to 5G Boolean class variable. Perfect. Now we have that getter. We save that. We come back up here and we're going to replace that now with get is connected to 5G. We'll run this. Perfect. Everything passes. All right. So typically we always created a test for that method that we created within our class. But one thing I'm going to point out is that it's going to be a little tough to test out make phone call because it doesn't return anything. So in this exercise, I'm not going to actually test this method make phone call. I'm just going to test the constructor. So I'm going to stop there and we're going to go back to our assignment. Abstract class design, step number 3. Looking over this, it says we need to assign a unique ID to every object that's created from one of these classes, the abstract entity class. So it looks like it wants us to create an abstract class called abstract entity. And it has one behavior, and that is to have an ID property that assigns to anything that is created from it. And then we need to add it to our class hierarchy in the correct place. All right, well, this is a big ask. Let's get to it. First things first, it said create an abstract class called abstract entity. So I'm going to create a class called abstract entity. And then up here, I'm going to type in abstract because it said it wanted to be an abstract class. Therefore, we need to add that keyword abstract. Now it said it wanted us to create an ID for this class and anything else that inherits from it. So easy enough, we're going to put an ID class variable here. That's just going to be an integer. Our IDs will be integers at this point. There we go. Nothing too complex just yet. Now, every time this abstract entity or any of its children that inherit from it, when an instance is created, we want to assign an ID immediately to it. How we can assign that is create a constructor that creates our ID for us. Now here comes the tricky part. What are we going to assign our ID to? If I was just to put 1 here, everything that is created from an abstract entity would always have the ID 1. That doesn't sound too unique. So how can we create something that can always increment our IDs so every ID that we have is unique? Well, here is the first thing we've seen now in these exercises where static will come into play that will be a huge benefit. Remember, static doesn't belong to the instances. It belongs directly to the class that is declared in. So no matter how many instances that you create, a static variable will always stay consistent to how the class manages it. What I'm saying from all that is if I created a static counter in this class, depending on how many instances I create, I can manipulate that static counter to essentially keep incrementing and remembering where it's at in that count to keep assigning IDs one after the other, hence making them unique. Now I know a verbal explanation might not have been the most clear here, so let's do it in practice. To create a static counter, what I'm going to do is say private static int, and then next ID, aka my counter. So what I can do here is that I can put in next ID here. So my ID for this abstract entity will be 1. Now this is great, but again, it's always going to be 1 if we don't do something to change it. So what I'm going to do here is say next ID plus plus, which is saying once I assign this ID to this instance of an abstract entity, increment next ID. Hence the next instance that's created will have an ID of 2. Now we might not just see exactly how this is all going to work, so let's keep going. Our instructions said we needed to implement abstract entity somewhere within our hierarchy we've created with computer, laptop, and smartphone. Now remember, abstract entities can't be created by themselves, so we have to have some class extending our abstract entity. I'm going to do it at the very tip top of our hierarchy, which was computer. I'm going to have computer extend abstract entity. So what does this mean now? Well, it means that everything that's in abstract entity, which is only that ID, is now brought into the computer class. Now, one more thing we need to do in abstract entity is that we have an ID, we're setting the ID here, but now how can we access this ID? It is private. The answer to that always is creating a getter. A big thing to note about IDs, which is the unique identifier for these classes, is that a getter is perfectly fine. It's great to have a getter for your ID, but a setter is typically not what you want to have for IDs. So I will never create a set ID in any of my classes. So now that we have this getter, let's go ahead and go back to our program class and test this out. From what we talked about, if we look up here, my smartphone is the first instance we create that is a child of computer, which therefore is a child of abstract entity. From what we talked about, abstract entity's first ID would be 1. Therefore, since smartphone is a direct descendant of abstract entity now, smartphone's ID should be 1. So let's test out that hypothesis. We can say get ID, which again is coming from that abstract entity abstract class, and we're going to comment out all the other system outs and then run this. And we see it's 1. So this hypothesis is correct. All right, the next thing we create is my laptop, which also extends from computer, which technically extends from abstract entity. So my laptop's ID should be incremented by 1, which therefore should make it 2. So I say my laptop.getID. I'm going to print that up to the screen. So now I should get 1 and then 2. Perfect. We got back 1 from the first system out, and then 2 from the second system out. So I know my laptop's ID is 2. Last but not least, let's test out this computer class here. Again, it should be incremented by 1, so my computer's ID should be 3. And it's 3. Perfect. Exactly what we want to see here. And that completes this third step. And that means we're finished here. Awesome job working through this entire exercise. I know we got a little into depth there with the tests. We're taking those tests now one step further to enhance our knowledge with JUnit. We also started to dabble with abstract classes here and how we can make identification more unique as we dive deeper into inheritance. Feel free to reach out with any questions. And as always, thanks for watching.